So when we were adding and subtracting, you kind of did it automatically. When you were adding these complex numbers, you added this bit to this bit, and this bit took care of itself. You added the real to the real and the complex to the complex. So each complex number has a real bit and an imaginary bit. So it looks something like a plus bi, something like that, or ib. The real bit and the imaginary bit. So R1 follows that example. This is a complex number. It's got a real bit, -1, and an imaginary bit. Now that can actually be graphed on something called an Argand diagram, which we'll do later, which has, instead of the x-axis is the real number line, but now the y-axis is an imaginary number line. But we'll get to there. So a complex number has a real part and imaginary part, and actually every number you've ever been dealing with so far had a real part and imaginary part. It was just the imaginary part was 0. Yeah. So the number 3 is actually 3 plus 0i, which we didn't do in year 7 for obvious reasons, but now you're doing it in year 12 HL. Yeah. So every real number has an imaginary part, but it just sits at 0 until now. Now we got imaginary parts, all real numbers. Complicated? A little bit. But it's useful to find roots at the moment, to finish off something that normally would stop here when we want to continue. Okay. We'll just look at i's, and then we come back to the multiplication. Okay. So if I is square root -1, what's I squared? You sure?
No, it should be 1 plus something.
It should be -1, shouldn't it?
That makes sense.
Are you pretty sure? Well, when a number, what's the square root of 2 squared? It's the thing in here, because that cancels out, yeah? Same here. This squared, the square root will go, and we got -1.
Yeah.
So I squared is -1. Or, yeah. What's I cubed?
No, it's root -1 again. Minus root -1. Isn't that 0?
Okay, well, what? That's root 1 times root 1 times root 1.
Oh, right. Okay.
Or root -1.
That's -1 times.
Now we already figured out that this much was -1. So it's -1 times minus root 1, which is what?
Negative I.
Oh, it is negative I.
Yeah, it's negative this or negative I. It's negative that, which is -1 times this, or just negative I for short, yeah. You know where I'm going next? What is this one?
Does it happen to be -1?
Which
one is which one?
I think it's 1.
Oh, it would be
0.
Guys, think about it. It's minus.
Yeah, well, we already know I squared is -1. And I to the power of 4 is I squared times I squared, isn't it? We should know that from our indices. So that's going to be -1 times -1, which is I to the power of 4 is 1.
Okay, we definitely did this last year.
I5.
It's I. I5 is I. I5 is I.
I've heard it just goes like that again.
Yes, because if you're starting off with 1 again, and you're multiplying it by this, you end up with this again. And then it keeps going in this 4-stage cycle. So every 4, it repeats. So I6 is -1, I7 is -I, and I8 then is 1. So it has this, and of course this is just I. So what's the cycle it goes? It goes I -1 minus I 1. I -1 minus I. Now that is becomes useful when we come to multiplying complex numbers, and we know what I to the power of 4 is. We know that straight away that's 1. On, yep, sure.
So I minus 1 minus I, 1 minus 1. I don't like
Yeah.
this. Definitely not between these.
Okay. Right, let's deal with the nuts and bolts, the arithmetic parts of complex numbers, i.e. adding them, subtracting them, multiplying them, and dividing them. I'm getting rid of this, hopefully you have it already.
So it loops after I5.
Yeah, every 4 it loops, yeah?
Every 4?
Every 4, yeah. Yeah. I to the power 1 is the same as I to the power 5. Yeah.
Okay, what is I to the, no, I to the 3,
I to the 3 when we read my book, it's minus
I to the 12.
Also minus I.
Okay.
Okay, good job.
So I'm going to call two complex numbers. The first one I'm going to call Z. I'm going to say 2 minus 4i, and the second one I'll call W, minus 3 plus 5i. Okay, there's two complex numbers, or two numbers. Z and W are used a lot in complex numbers. Same as X and Y are used a lot in algebra. Z and W tend to be the ones they use most often. So you'll see those in textbook questions. They'll introduce two complex numbers or two numbers, and they say deal with these for the rest of the question. If I want to add them, so what is Z plus W?
Z.
1 plus I,
Which is 2 minus 4i plus minus 3 plus 5i. Or you can keep them in brackets like that.
So minus 4i and 5i will become I.
Yes.
And then minus 3, 2 will become minus 1.
So minus 1 plus I. So you add the real to real and imaginary to imaginary.
it's like I do
So it's just, yeah, it's a bit like dealing with, oh, what's 2 plus 3x plus 6 plus 5x? You go, oh, well, that's 2, that's 8, and that's 8x. So you add the real, these bits and these bits together. It's like terms, if you want. Okay, same for subtraction then.
Are we subtracting them?
Yeah, we're going to subtract them. Z minus W, which would be 2 minus 4i minus 3 plus 5i. Now be careful with signs.
So 5 and then
minus 9i,
Okay. Yeah, 2 minus 3 is 5, correct?
5
And
minus 9i.
minus 4 minus 5i is minus 9i. Yes. So same thing. Subtract the real from the real and the imaginary from the imaginary. Okay. Multiplying.
You multiply and then you get everything? Or do you still just do the right?
Well, we'll see. ZW now. We're doing ZW, which is Z times W.
multiply each
It's the same as multiplying in algebra. Yeah, you got to multiply each. The FOIL method, if you use the FOIL method, or just make sure everything gets multiplied by everything else. 4 multiplications here. 2 by both those, and minus 4i by both those. So 2 by that is minus 6. 2 by this, 10i. These two together, plus 12i. And the last two together, minus 20i squared.
Doesn't that, wait, that's just,
Yes, right?
so be plus 20.
That's 12i, yeah? Yeah.
So wouldn't it just be plus 20 because I squared is
Very good. Earlier on, we did this whole thing where I was the square root of minus 1, and I squared is minus 1.
So we could just do that as
This I squared, and this comes up in every complex numbers, is minus 1. So technically, we've 6 plus 22i, and now we've minus 20. You'd never write it like this because you get here quicker than I do, but this I squared is minus 1. And minus 1 times minus 20 is plus 20. Now I'm doing this very slowly. And now I can add these together, so I get 14 plus 22i. Now normally you would probably skip from here to here. If you want, you can take a little bit of time, but anytime you see I squared, it is minus 1. I squared is minus 1.
because follow that like 4
Yes, it follows that pattern. So I to the 3 and 4 and 5 and 6 don't come up that often, a little bit later on in the unit, but I squared will come up from day 1. Okay, and the last one. Dividing, yes. So if I have z divided by w, or form a quotient, 2 minus 4i minus 3 plus 5i. How do I do that? How would I divide that into that?
I couldn't tell you.
It's not long division, but it does remind me of something from GCSE.
It's like fractions. I turn it into a fraction.
What does it remind?
There. Sum. It's like 2 divided by 5i minus 4 divided by 5i, and then something minus 3, 4i.
Good. An attempt, solid attempt. But do you remember in GCSE when we had something like this?
Oh, rationalization.
Oh, it is rationalization.
So we rationalized the denominator. We wanted the
So
denominator.
we get the I squared.
So yes. So what? Yes, exactly. When we square, we realize the denominator. It's called, not rationalize. That'd be making it a rational number. But we're turning this from irrational to rational. We're going to turn this from complex to real, which is realizing. Realizing the denominator is all we can do. We can't. It's not going to fit in once or a half time. We're just going to realize the denominator. We're going to make it a real number. So that means I must multiply it by something. What am I going to multiply it by? No, it's similar to the surd. When we had 2 plus root 3, what did I multiply by?
The denominator.
Was it the same?
Yes.
No,
It was negative.
it was negative. It was negative to create the fact that the middle two terms would subtract and cancel. So the square roots would go in this. The same thing happens here. We need to multiply by this. Now this has a special term. If w is this, w with an asterisk after it is this, and this is called the complex conjugate. The complex conjugate, w with an asterisk, and you multiply the numerator and denominator by it in order to realize the denominator, which we're going to do now.
Minus 3 minus 5i.
Yeah, see, can you do it faster than me? Go for it.
Oh, once.
So this is a kind of side note. Now I'm going to do the question here. So it's a number of multiplications again, similar to what we had over here. This has to be times by this has to be times by this. Yeah. So 2 times minus 3 is minus 6. I hope so. Plus 12i here. These two. Now, this gives 20. And I squared is minus 1. So I think it's going to be minus 20 here at the end.
What? Sir, aren't you timesing 3 by 3?
I'm doing the top.
Oh, you're doing the top one?
Yeah. Yeah, do both. You have to do both. So you're expecting, if realization is the key, you're expecting the denominator to be gone, no i's anymore. We're hoping for a normal number.
I got the bottom then.
9
The bottom would be 0, not 1, I mean. The bottom would be
plus 15i minus 15i minus 25i squared, which is
minus 25.
plus 25.
Okay, so I got it.
Because remember,
I finished.
that comes from
Let's go.
minus 25i squared, and I squared is minus 1. So let's tidy this up. We get minus 26 here, plus 2i, all over 34.
34. Oh, 9 plus 25 is 34 though.
Yeah, all over 34.
I want to watch this video.
Is, yeah, the bloopers. Can I simplify this?
2?
Yeah, 2 goes into everything, so I can't simplify it. So this could be minus 13 plus I all over 17. Can I do this?
Are those all those are right?
Can I do that?
Yeah, you can.
Yes, I can do that as well.
What can you do?
Is that simplified, sir?
1/6.
Yeah, this is fully simplified. Yeah.
Simplified would be like
I know, but why what?
Uh, depending on the question. Both of these would be fully simplified. But sometimes they ask for it in A plus BI form, where you have to give A then as 13 over 17, and B would be 1 over 17.
What happens to the negative next to the 13? Does that disappear?
It shouldn't, because, yeah, writing it too fast, yeah. Okay. I suppose if we remember what was written earlier on, we can now do the product of what we did earlier. It was pretty nasty.
Is it root? Wait, is the I
What's a root?
separated from the root? Or is it like times?
Yeah,
Is
it's
it-
all we're doing.
it's times the root. It's times the root.
Times roots are technically separated.
The I is part of the root. Yes. It doesn't, like, if you go back to when you did the quadratics for the first time, when you came across the discriminant would tell you if it had 2 real roots, a repeated root,
Is that negative?
or no roots.
Just 1 minus
No real roots.
If it's like equal to 0, then it's 1 minus root.
One repeated
If
root.
it's greater, then it's 2, and then it's
Yes.
Just the I squared.
So this is the last case where you got that negative number and you dismissed it as having no real roots.
the discriminant is then 2b over a.
Discriminant is b squared minus 4ac.
Oh, that one.
Yes.
So instead of just leaving it at no roots, you gotta find those.
Now we can find, now there are roots, they are an imaginary roots. They're somewhere, they're just not on the x-axis. Okay? Okay, we left the product of the earlier question earlier on. I'm trying to remember what they, was it minus 1 plus minus root 3i? Was that it? Was that it? Okay, so now I can multiply these together. Minus 1 plus root 3i times minus 1 minus root 3i. Okay, so now I can multiply these. Minus 1 times minus 1 is 2. 1. Positive 1.
Sir, Billy just said that. Billy was just talking about.
Oh, God.
And so it's
Minus 1 times is plus root 3i, yeah?
Minus root 3i.
These two together,
minus root 3i.
minus
Cancel out.
root 3i, they will cancel. And the last two, now these are crucial.
3i.
It's 3i squared.
It's going to be minus 3i squared.
So it
Root,
is squared.
It's 1 plus
and that,
3
these cancel. 1
plus 3.
minus 3 times minus 1, which is 1 plus 3. Remember, that's minus 1, which is 4, which we had at the start. Okay. Time for you to do some